you get for this one in words? In words, what was the end behavior? Down and down. So then as x goes to infinity, f of x goes to? And then as x goes to negative infinity, f of x goes to? Yes, awesome. This one is? It's actually up and down, yeah. Because once again, odd and negative would be like a negative line. So yeah, awesome. So as x goes to infinity, f of x goes to? Negative infinity. And then as x goes to negative infinity, f of x goes to? Okay, good. Now when you did this, you subtracted this from this, then this from this, then this from this, and you didn't get the same thing, did you? No. Then you did this and this, and you got -6 and -6. Therefore, it took two differences, so it is degree 2, or quadratic would be equally correct. Awesome. So if you got those right, you should feel good about 2-1. I have learned, oh, it's 1-1. 1-1, you should feel good about it. Okay, are you good with 1-2? So, one of the most missed problems on this test is people not being able to do even, odd, or neither right. There's going to be at least 2 problems of this. If you can't do them, your score is automatically going to be down in the low 90s. So you got to be able to do them. Tell me if it's even, odd, or neither, and then simplify correctly. So my question is, real quick, where do we start? How do we use algebra? How do we start? You have to use algebra. I'm telling you, you have to use algebra. So, where do we start? Plug in negative x, ready, go. When we plug in something, we use parentheses, go. Okay, here we go. So we know we're plugging in negative x, so we use parentheses anytime we plug something in. Negative x cubed over negative x squared minus negative x to the 5th. Is everybody good there? Yes. So let's simplify this correctly. An odd power with a negative is going to be negatives. We have negative x cubed on top. Does everybody agree? Now on bottom, this will become positive, because something squared, a negative squared is positive. So we have x squared. Now guys, ignore this minus sign for a second. We got to ignore it. Look right here. Negative x to the 5th. Won't it stay negative x to the 5th? Well, then we have a minus sign. So it's plus x to the 5th. Now everybody, remember, if you have a negative in front, we factor it out, correct? Well, look at that. There's a negative in front here. So I'm going to pull it out in front. I'm going to pull out -1. Now remember, so if I pull it out, then I have an x cubed, true? On bottom, x squared plus x to the 5th. It doesn't have to be with the top or bottom. It can't be with both, right? Does everybody see? I'm putting it in front. Okay, now compare it to the original function. Is it the original? No. Is it -1 times the original? Yes. Is it? No. It's not. This had a minus sign. This has a plus sign. Does everybody see? This is neither. Even if I took the -1 down here, this would be negative and this would be negative. That does not compare to this. So, neither. If you made an error, that's something you might want to go back and re-practice, because I'm telling you, it's worth a lot on the test. Here we go. So, don't be the person, yes. Just knowing how, like, sweet. Okay, guys, don't be the person that breaks the forbidden rule and squares that and squares that. You can't do it because of the subtraction sign. So this is b minus 3, b minus 3. True? Yes. Okay, let's multiply out. When we're multiplying 3 functions, I'm telling you, multiply 2 together, combine like terms, then multiply in the third. I'm going to multiply these 2 together. So when I distribute all this out, I should get b squared minus 6b plus 9. True? Yes. So then we have a b times all that stuff. So if I take b and multiply it in, I'll finally have b cubed minus 6b squared plus 9b's. Awesome. Who got that one right? Yay. Okay, erase. Good. If you're still struggling with even, odd, or neither, go back and practice some more. Okay. Find the zeros, 2-3. How do we find zeros? We factor it. We try factoring it. We try solving by factoring. Then right here my instructions are find the linear factors given these solutions. I just want the linear factors. So after this, and then find the max and min of that. Do this one. So what were your solutions or zeros? 0, 2, and -1. Good. All right. Now everybody, because all of those zeros only have happened one time. We don't need to write multiplicity of 1, but it does have a multiplicity of 1, correct? So won't it, because it's an odd multiplicity, all of them, they'll cross through, not bounce, right? Just a side note. Okay, good. Those are true. Now right here, I just asked you for the linear factors. So what did you get? X
minus 3 squared.
Good.
X plus 1.
Times x plus 1. True. I would not mark it wrong if you would have went x minus 3 times x minus 3 times x plus 1. Now let's pretend that I would have said, write the polynomial in standard form. You'd write it like this. You then multiply 2 together, combine like terms, and then multiply in the third. Okay, awesome. So what is the relative max? X, Y point.
Negative 0.56 and
0.76.
0.76.
Awesome. And then my min, you're right, that is true. My min is 0.56 and then negative 0.76. Yeah. Awesome. Now notice they are like exact opposites, right? That won't always happen. Just in this one it happened too. So, but awesome, yes. Yes, so good question. Yes, with relative max and min, we would always put it as an XY point. Now, if I go to a story problem and it says, tell me the maximum volume, they only want the output, because that would be the volume. Yeah, I should have done it as an XY point. My bad on that. Yeah, good question. Do write relative max and min as a XY point. Okay, awesome. Good. You guys should feel good if you were able to do all that about what we've learned so far in Sec 3. So let's get going. Now, today is the last day. This is the last day that we're going to be making sure you can solve a quadratic equation at 100% accuracy. Okay, awesome. So it says, solve by graphing. So if I asked you to solve by graphing, you would graph it and say x equals negative 1 and x equals 2. True. Now, if I said to you solve by factoring, we would first put it in standard form and set it equal to 0. That's important. Then just remember that we look to see if we can quick factor or if we have to long factor. Then we'll do it. We know how to do that. We've took a few days and done that. So that's the first thing you should try. Because on the test, I'm not going to say solve by factoring like I do today. I'm going to say solve the quadratic, and the first thing you check is, does it factor? So just watch. You know how to factor, so just watch. We have x squared. I need to get it set equal to 0. So subtract 5x, subtract 5x. Put it in standard form. So minus 5x plus 6 equals 0. I would say I need to check if it factors. What multiplies to be 6 and adds up to be negative 5. 1 times 6 and also 2 times 3. But let's see which one actually works. We put the negative here. That would work over here, but not here. Because a negative times a positive is not positive. So wouldn't this work? Negative, negative?
Yeah.
And it works over here. So we would say this quick factors to be x minus 2 and x minus 3. Now this one is solving, so we're just using factoring, therefore x equals 2 and 3. Okay, let's see, we have this one. Guys, I always keep the leading term I always keep positive. So people always want to bring this over because it's only one step. Instead, bring these over. This doesn't take any longer. So we would have 4x squared minus x minus 3 equals 0. Then we would do our long factoring, correct? We'll multiply to be negative 12, adds up to be negative 1, 4 times 3, negative 4, and we would drop and break and go through. Do we need me to long factor on here? I didn't think so, so I won't waste your time. Do 1 through 8, ready, go. What if we have something where we should be solving by taking square roots? Here's one you should be solving by taking square roots. We already have kind of gone over this, honestly. So if we have something of this format, ax squared plus c, if we're missing bx, then if you look at this, notice there's only one x. There's not another x in here. So we can literally just piece by piece get x alone and solve that way. Does that make sense? That is the easiest way if there's only one x. So now this is also considered the same type of thing. This is in like kind of like vertex form, but do you notice something? There's still only one x. Just like right here, there's only one x. There's only one x. There's only one x. Do you see? We would solve these the same. So maybe just watch. So you'd say, okay, I need to get x alone. I'm solving for x. So what would I do first? Add 8, then divide by 18. You got to do that before you square root it. So you have to isolate the square. So x squared is equal to 8 over 18. Now here's my suggestion, everybody. Simplify that if possible. So we have x squared equals what? They both divide by 2. So that becomes 4 over 9. So we have x squared equals 4 over 9. Now we'll take the square root of both sides. Now we have root cancel out power. X is equal to, when solving and taking a square root, you need a plus or minus. Next rule, listen, if you have a fraction and a square root, no matter what, you split up the top from the bottom. We have a square root of 4 over the square root of 9. So in this problem, it actually came out nice and pretty. X is equal to plus and minus 2/3. There's our two solutions. Okay, let's go on to the next one. So they're not always going to come out that pretty. They're not always going to come out that pretty. Here we go. So what should I do first? Subtract 15, then divide by, so I have this. X squared is equal to negative 15 over 2. Does that simplify? No. So we got to just keep going then. Square root both sides. Okay, so we have x is equal to plus and minus. Now, once again, listen to the rule. If you have a fraction, you need to split up the top from the bottom. The negative, you're going to put on the top always, just because. We want i's on top, not on bottom. So we have the square root of negative 15 over the square root of 2. So we have x is equal to plus and minus. Let's simplify the top, and then we'll simplify the bottom. So what can I pull out on top? I, correct? But then 5 times 3 doesn't have 2, so we can't pull out any of those. So we have the square root of 15. Now on bottom, the square root of 2 does not simplify, true? Now just a reminder, it is not considered quote-unquote simplified to have a radical in the denominator. So we have to quickly rationalize our denominator, meaning write it in a prettier format. So everybody, we need this radical to go away. So we're going to multiply by actually known, but good thought, you're on the right track. So we're going to multiply by root 2. Now why? Because now isn't that root 4? Isn't there 2 2's?
Yeah.
So it's root 4 now, so we'll be good. But if you do that to the bottom, you got to do it to the top. Now look, why am I not changing it? I'm multiplying by 1. Isn't this over this a 1? Yeah. So I'm just like manipulating this, writing it in the same equal mathematical statement, it's just a prettier form. So we have plus or minus, we have an I. If you have something under a radical and something under a radical, you can put them under the same radical. So we have root 30, which still doesn't simplify. And then all over square root of 4, which is 2. Now we're good. Moving on. Okay, now look, you would not, listen, because even though I said this first hour, people were still doing this. Do not start multiplying this bad boy out. Why? Because it's much easier just to get x alone. Get x alone. There's only one x, so we can do that. So what should I do first? Yep, subtract 18. We got to isolate the square, just like we did here. Isolate the square, isolate the square. So we have negative 2, x minus 1 squared equals negative 18. Then what? Yep, very important that we divide by negative 2 first. So we have x minus 1 squared equals 9, right? Now we'd have to undo the square with a square root. We just solved and we took a square root. We need the plus and minus right here. So x minus 1 equals plus and minus 3. So we have x minus 1 equals positive 3, x minus 1 equals negative 3. Therefore, x equals, add 1, 4, add 1, negative 2. Right? Sweet. Okay, practice some of that caliber. So what you're going to do is, right now, I want you to do, specifically, I'm changing my mind. I want you to do 9, 10, and then find some blank room and do this one and this one. You're going to be tested on it, and there's not any on the worksheet like this. So we got to practice. So just pick a blank spot, make a little box, and then just write it down. Here, math does not change. So what's my first step? Add 2. So we have negative x minus 3 squared equals positive 2. Guys, you can't take the negative in. That negative is not squared. Don't do it. What would be my next step?
Divide by negative.
Divide by negative 1. So we actually have x minus 3 squared equals negative 2. Math doesn't change. What's our next step?
Square root.
Square root both sides. Now math doesn't change. So what happens usually when we take a square root? We need a what? X minus 3 is equal to, we need a plus or minus. So we have plus or minus. Can't I pull out an I?
Yeah.
I root 2. Okay, good. Now what's our last step? Add 3. Add 3. Okay, so we have x is equal to. Now guys, think about the quadratic formula. X equals negative b plus or minus the square root. So don't you think we should probably write the positive 3 first?
Yes.
Yes, we should. It's just prettier. So we have positive 3. Then we have a plus or minus I root 2. A lot of you put the plus and minus on the 3. That wouldn't make sense. Does everybody see why? For those of you that did do that. Okay, cool. This would be our answer. Those of you that split it up, just as great. You're just as great. Okay. Sweet. Next type. So guys, if you try factoring and it doesn't work, and if you can't solve by the method we just saw, then we'll solve using the quadratic formula. We don't solve using completing the square. So, if we have imaginary solutions, that means it never crosses. It might cross though and have real solutions. They'll just be, if they need the quadratic formula, they're irrational. Meaning the radical doesn't break down perfectly. Like the square root of 9 is 3, that one would be rational. Does everybody see? Okay, cool. Awesome. So, one more thing to note. Underneath the square root tells us everything we need to know about what type of solutions and how many we'll have. It's called the discriminant if we want to be technical. Now guys, think about this. Think about why. Back in Sec 2, you might have just memorized this. But don't. It's hard to remember it. Don't memorize it. Like, let's think about why it makes sense. Okay, everybody. What's under the square root is going to determine if we have imaginary solutions, real, correct? Yeah. Imaginary or real. Think about why. If we have the square root of a negative number, won't they be imaginary? Yeah. Okay, so you're saying if I calculate this under here, and it's negative, it's going to be imaginary. Yes. True. Now if we have the square root and we calculate this and it's a positive number, won't they be real? They're not imaginary, so they're real. And then what if we calculate that and we get the square root of 0? Well, isn't the square root of 0 plus and minus 0? Is adding 0 and subtracting 0 any different? No, so that would be, we have real solutions that are not imaginary, but there's only one of them. So this one would have 2 imaginary because of the plus or minus. This one would have 2 reals. And then this one would just be 1 real. It's real, but there's only 1. Okay, sweet. So, just watch. You know how to do the quadratic formula. However, I'm reminding you of the rules because you're going to have some advanced ones on here. We have to first get it set equal to 0 and put it in standard form. 2x squared minus x minus 4 equals 0. Does everybody see my first step? Here's my a value. Here's my b value. Here's my c. So we'd say x equals negative b, so that'd be positive 1, plus or minus the square root. Remember, you must use parentheses of b squared minus 4 times a times c, and then all over 2 times a. So can't that, I can just put 4, can't I? Yes. Now remember, your next step, the requirement is to calculate that and only that. Type it in. Only that. Don't type in the square root part. Tell me what's under my radical here. X equals 1 plus or minus the square root of what? Did everybody get 33? So now you'd say, okay, cool. Do you guys see how it was positive? So we have 2 real solutions, which we can see that right here. Here's 2 real. They're irrational, but they're real. Then I go off to the side and say, okay, does root 33 break down? 3 times 11? Nope, so I'm done. Are we good? Okay, next one. First, get it set equal to 0. 3x squared plus x plus 3 equals 0. So x equals negative b, so won't that be negative 1? Plus or minus the square root of b squared. So 1 squared minus 4 times a times c. All over 2 times a, so that'd be 6. Ready, go. Calculate that. You got what? Negative 35. So then you go off to the side and say, okay, I need to simplify negative 35. 5 times 7. Okay, we can't pull anything out, but we can pull out a I. I think we've got negative 35 all day. So if so, make sure you type it in exactly as you see it. Make sure it's a minus sign, not a negative sign. So we would have x is equal to negative 1 plus or minus. We pulled out an I. So I root 35 all over 6. Now look, when we had a negative underneath, we had 2 imaginary solutions. It's all making sense. Okay, go to 23. There's a reason I'm doing this one on your worksheet. Yours are going to sometimes be, you're going to have to simplify, so you'll see what I mean by that. Here we go. First of all, get it set equal to 0. I highly recommend keeping the leading term always positive, so even though you feel like you might want to bring that over, don't. Bring these over. So add 8x and subtract 13. So we have a 2x squared plus 8x minus 13 equals 0. Now we would, on a test, we'd try factoring. If it doesn't factor, we'd quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4 times a times c, and that's all over 2 times 2. Your next step is to calculate what's underneath the radical. So you should all do that. Ready, go. Okay? So then we go off to the side and say, I need to break this bad boy down. 168. Give me some factors. What are two things that multiply to be 168? I just did on mine 2 times 84. 84 breaks down into 2 times 42. Then 42 breaks down into 6 times 7. 6 breaks down into 2 times 3. Are we good? Now watch what people do. It's so sad. They double dip, which is gross. What they do is they say, oh, there's a 6, a 2, and a 3 under here. Well, that doesn't make sense, does it? 6 is rewritten as 2 times 3. They're not both there. Do you guys all understand that? Okay, cool. So 6 isn't there, 42 is not there, and 84 is not there. We've rewritten them as different things. Okay, cool. So now pull out groups of 2. Pull out a 2, 2, 3, and 7. None of those can come out, can they? All right, so we pulled out a 2, and then left was the root of 2 times 3 times 7, which is 42. Okay, let's insert that in. X is equal to -8 plus or minus 2 root 42s all over 4. Then remember, if all three things can divide by something in common, something not under the radical, no, but if all three things divide by something in common, then you can divide it out. Only if all three things do, though. What do they all divide by? 2. So this becomes a 2, this becomes a 1, this becomes a 4. So we divided all of those by 2. So x is equal to -4 plus or minus 1 root 42, so we wouldn't write the 1. And then that's all over 2. Would I divide those out next? Heck no! You can't do that. There's plus signs and minus signs. You don't divide across plus signs, everyone. That's as far as it can go. Don't do it. Don't do it. Okay, cool. Okay. So now we're going to just do a quick review before I set you free for a second, talking about complex numbers. They relate to quadratics, so that's why we throw this in at the same time. Complex numbers have real parts and imaginary parts. We always write complex numbers as a plus bi. So the real part comes first, the imaginary comes second. So here's the thing, guys. When adding and subtracting complex numbers, you can only combine real parts with real parts and imaginary parts with imaginary parts. So let's go ahead and simplify this. 2 plus 2i minus 3 minus 7i. So we have a 2 plus 2i, true. Then we have a minus all that stuff. So we need to distribute the negative. So we have a minus 3 plus 7i. Does everybody see? Combine real with real, imaginary with imaginary. So 2 minus 3, -1. 2i plus 7i is plus 9i. Have we written it in a plus bi form? Yes. So we're done. I am going to mark it wrong. Well, I'm going to mark it and tell you to fix it if I see you write it as 9i minus 1. Okay, cool. Let's look at this one. It's multiplication, so let's double distribute. We have an 8. We have plus 8i's. We have minus 2i's. And then right here's where people usually mess up. So we would have -i times 2i is -2i squared. So then remember, I squared is equal -1. So isn't this minus 2 times -1? Which is plus 2. Plus 2. Okay, so now positive 2 plus 8. 10, 8i minus 2i. Plus 6i. A plus bi, and I'm done. Okay, cool. So, looking at this one, if I ask you to simplify, here's all you have to know. Other teachers have you do this by memorizing a whole bunch of things. You only need to know 2 things. Let's make it easy. So we know we have i's and we have I squared. That's what we know about i's. What is I squared? -1. A lot of your other teachers then have you do I cubed and I to the 4th. That's kind of a lot to remember. I just focus on these 2. That's all I need. Okay, simplify this down. So I to the 50. We want to rewrite this in terms of I to the 1st and I squared possibly, kind of, in some way. We want to rewrite this so that we can simplify it. So you can do it many different ways. So first of all, can we do, I don't know, there's many different options. Let's say we had an I squared. Couldn't we raise it to something? Raise the power to a power and you multiply. What power could we put up here? 25. Okay, well, does that help us? Yeah, why? Because I squared is -1, so we actually have -1 to the 25th power. Isn't a negative to an odd degree just negative? So my answer is -1. Not too bad, right? There was other ways to do it. But I don't really, I want I squared somewhere, you know? Or an I. So, okay, look at number I to the 7th. This is how, there's so many ways to do this one. Look, you can go like this. I squared times by I squared times by I squared. 2, 4, 6. Don't I need times I then? I to the 1st. You see how there's 7? Degree 7. That's one way of doing it. So let's calculate that. That's -1 times -1 times -1 times by I, which would be -I. Here's another way you could have done it. You could have said, oh, well, that's I squared cubed. That's 6, and then we need times by I. So then we have a -1 cubed times I, which is -I. Do you see how there's many different ways? It's just manipulating it. There's not one right way to do it. So how about this one? -2I to the 27th. That's just a time sign. So the -2 is just -2. How could we possibly, there's not one right answer. Can anyone see a way we could possibly rewrite 27? We need, sorry, what? So you're saying, okay, 9 and 3, so you're saying if we did I to the 9 times, oh wait, 9 raised to the 3rd, or is that what you mean? Oh, 3 and then raised to the 9th? Because if you're multiplying, it has to be raised a power to a power, right? If you put 3 here, it has to be this. It can't be times by I to the 9th, because then you'd be adding, right? Okay, so that would work, but then it's still not super helpful as much. I mean, it is helpful. You got to manipulate it more. -2. Actually, what are we actually looking at? We want I squared, or I, right? So we're actually doing I squared times I to the 9th. True? This is a hard way of doing it, but that's okay. -2, and this is actually -1 times I, true? So that's really -2 times -I to the 9th. We gotta keep going. First of all, a negative to the 9th power is a negative, true? Yes. So we definitely know we have a negative in front. We now have a negative, so it'd be positive this, 2I to the 9th. Okay, well at least it's smaller. So now we can do I to the 9th. 2I squared, I squared, I squared. 2, 4, 6, I squared, I. Isn't that 9? This is another hard way to do it, but that's 2 times -1 times -1 times -1. Don't I need another -1? And then times I. So what will that be? Positive 2I. Yes. There was a much, much quicker way, but that's okay. If we were desperate, right? I mean, there's not one right way. How I would have probably done it is tricky though. You get better at seeing it as you practice. Watch what I would have done. I would have went like this. That was great. Still got it right. -2, I would have said, and then I would have said I squared raised to the 13th. Well, that's only 26. So then I would have said times by I to the 1st. Because then we would have had -2 times -1 to the 13th times I. And then a negative to the odd is positive. So we'd have positive 2I. Yep, a negative times a negative made it positive.
Oh.
Yeah. Many correct ways. You just get better at it as you practice. So, finish the worksheet and be careful. It's written like it's supposed to look like blood. Not really, it's just kind of...